Today we take up solving inequalities. Part of this you've done before, some of this is new. Part of the new stuff we need to deal with is at the very beginning where we need to learn some new notation. In my opinion, a much easier way to deal with inequalities. For years we have beat you to death with all those lovely less thans and greater thans. And instead we're going to learn interval notation here momentarily. But before we do that, I need to talk a little bit about also what you're finding with some what's called set notation. In the past, we have solved some problems and we have had a difference between whether a problem said, in this case, A or B, or A and B. And we know from the past that when we had or problems, it's saying anything in set A or anything in set B is a solution. The way we typically write it in set builder notation, which is actually way easier, you will see it written as A, kind of a U-shaped symbol, B. That U-shaped symbol actually means union. It's a union of set A and set B. So if you have A or B, you're doing the union of A or B. So in this case, union means to join them together. What are all the numbers in both sets? So we would literally combine these two sets, and I'm going to try to get the numerical order here, and I would have the union. Or meant combine them together, union means combine them together. And on the other hand, said it had to be numbers that were in set A and they were in set B. The symbol for that is an upside down U, and it is actually called an intersection. So we're finding the intersection of set A and set B, which means what are the numbers that are in both sets. So if you're looking here for the numbers in both sets, you would find that, okay, -5 isn't in both, -3 isn't in both, -2 isn't in both. They do both have a 0 and a 2. That's it. So the intersection would simply be just those two numbers because they're in both sets. From here on out, we're going to use unions and intersections quite frequently. Today you will also see ands and ors, but the unions and intersections are going to come up within our final answers. Okay, the other thing you need to learn is what is called interval notation. Instead of writing x is less than 3, which we learned in the past that we graphed it with a 3, it wasn't equal to 3, so we open circled it, and we shaded it to the left, which that caused a lot of confusion for people to keep straight. If you do interval notation, you simply do what's the starting and ending point of the interval. So of this shaded region, what is the farthest left point we would have? Well, it would be as far left as you could go on the number line, which in this case would be -infinity. You put a comma, and then you write down the farthest right point. Well, the farthest right point is 3. Okay, here's the kicker to it. How do we do the open and closed circles? If you have less than or equal to's, greater than or equal to's, or in other words, closed circles, if it has a closed circle, we use brackets as our symbol. A bracket means that it can equal that number. That number is included in the solution. If it's just a less than or greater than, in other words, an open circle, we put parentheses on it. And the parentheses could, of course, go either way. The brackets could, of course, go either way. So in this case, our -infinity to 3 interval, well, the question is, can I do a bracket or a parenthesis on -infinity? Can I equal -infinity? Well, since there is no exact number that is -infinity, no, you can never equal it. Infinities are always parentheses. In this case, the 3 is an open circle. It can't equal 3, so it's also a parenthesis. That would be the interval, read the interval from -infinity to 3. Okay, second example over here, I have -3 and 8. It says, you'll remember that this notation was when we squeezed it between two numbers. So the interval has to run from -3 to 8, so we would know that if we're doing interval notation immediately. Those are our two numbers. The question is brackets or parentheses. Well, it can't equal -3, so that's a parenthesis. It can equal 8, so it becomes a bracket. The tough part of interval notation is you have to know when you're talking about intervals and not coordinates, because some intervals can look like a coordinate, a point. So you have to understand the situation and know which kind of way the notation is being used. Okay, we're going to go over here then and try actually doing a union with something in interval notation. Now, I know that you'll get good and you can look at these, but I expect to see a number line drawn on these problems. So you would graph this, negative infinity to 6. And so I like to color code these. Negative infinity means I would have everything coming up to 6. And the beauty of interval notation is we use the brackets and the parentheses on the number line instead of doing open and closed circles. It is so much easier. Okay, then I also need to put 1 and 10 on there. So I'm going to do 1, I'm going to do 10. And this one has a parenthesis at 1 going up to and including 10 with a bracket. Now in this problem, I did a union. I have the upward U. Union means to do what? A union is to join. So what it's wanting me to do is to join this together in one big interval. So in other words, what's the interval that includes everything we have shaded? Well, we have shaded everything from negative infinity. It's solid, clear up through 10. So our solution would be the interval from negative infinity to 10, 10 with a bracket. Okay, if I come over here and do the second one, you'll notice this one's the exact same problem. I actually don't need to rewrite it. I just need to look at the same picture, but the difference is on this one, I asked for the intersection. Since I asked for the intersection, that means I have to look for where did the two overlap. So now you're looking for where these two solutions overlap each other. Looking for where you see two colors. And of course, hopefully you're going, well, hey, I see two colors. They're overlapping starting at 1 and going to 6. 1 has a parenthesis on it, 6 has a bracket on it. So my intersection or solutions where they cross each other is from parenthesis 1 to 6 bracket. Personally, I've always preferred interval notation because I think it's so visual. I can see what I'm talking about, this interval to this interval. I find it less confusing than less than and greater than. So now, the rest of this section, we're going to solve inequalities, but we're going to write our final answers in interval notation. So as far as solving the inequalities, it's what you've been doing for years. We need to solve for the variable. We need to treat the less than just like an equal sign, but remembering the one special characteristic of inequalities, when you divide by a negative, you have to switch the direction, and so you would say x is greater than negative 5. That would be our only change with these. I also want to, well, so I'll point this out at the end. Let's go ahead and solve this one. So if we solve this problem here, we would need to solve for m. I need to distribute the negative sign, so I'm going to make that negative 5 minus 3m. Over here, I'm going to distribute the 2, make that 2m plus 8. I'm going to combine like terms, so that's really 3 minus 3m. Add 9 and 8, I get 17 plus 2m. And last but not least, with inequalities, you always want your variables to be positive. It keeps you from having to worry about dividing by negatives. So I'm going to add 3m, which will give me 5m. Subtract 17, which will give me negative 14, not negative 20. And then divide by 5. What they want, however, is they want you to graph the solution and write an interval notation. So if we graph that solution, we know negative 14/5 is on the number line. The question is, which way should I shade? And we know that that's really saying m is greater than negative 14. If you recall, if the sign is on, if the variable's on the left, the arrow's pointing you in the correct direction, so we would be shading this one from 2 down. But if, in this case, m is on the right, so we actually need to shade the opposite direction, so we actually need to go upward to shade this thing. But we're going to do interval notation, so the question is, should I bracket or parentheses the 14/5? Well, it's not equal to, so it would be a parenthesis. Now you can write your answer in interval notation really easy. My left-hand point is negative 14/5. My right-hand point of this shaded region is infinity. I know I need a parenthesis there. Infinities always have parentheses, and there would be my solution in interval notation. Okay, a couple special cases that can come up here. What if you solve a problem and your x's cancel out and you are left with something like 2 is less than 5, no variables? Well, 2 is less than 5 is always true. 2 is always less than 5. So therefore, if that happens, it's just like when you're solving with equal signs. If that happens, that's a true statement, so that means it's true for all solutions. You may write your answer in this case as all reals, or if you're in interval notation, you can write it from negative infinity to positive infinity. I am okay with either one. Use the one of preference of your choice on those. Now, on the other hand, if you had ended up with a solution of 2 is greater than 5, something that's never true, 2 is not greater than 5, then your answer is a no solution. I would prefer no solution or the empty set. However, you should be aware that your book does the empty set as brackets empty set. So any of those are acceptable answers. Moving onward then. Reminding you how to solve compound inequalities. Inequalities that have 2 parts to them. You'll notice the one on the left has 2 inequalities in it, which is strange. The one on the right is 2 separate problems, but it's got an or in between it. You'll hopefully remember that this one on the left, you simply need to split it up into 2 problems, because what it's saying is 8 plus 5x is less than or equal to 3x minus 5, and 3x minus 5 is less than 9 minus 2x. You must split it into 2 parts and keep the middle part in both sections. So the middle part has to go into both equations. It's always an and in the middle on these types of problems. Then it's just a matter of solving it like usual. I would bring 3x over and get 2x, subtract 8 and have negative 13. Divide by 2, x is less than or equal to negative 13 halves. On the other side, add 2x, that would be 5x is less than 14. Divide by 5, x is less than 14 fifths. Now, since it's an and is the same thing as an intersection, so we have to graph this and find out where these 2 intersect each other. So I would need negative 13 halves and 14 fifths. And I would come over here and grab some colors. And I would have x is less than or equal to negative 13 halves. I would prefer you do this in interval notation. So you're going to bracket it. Less than says go this way. 14 fifths. X is less than 14 fifths. That's going to be a parenthesis, and you need to know which way. It's going less than also, so it's going to come left, but it's going to have to be a parenthesis. So if I look for where do those 2 overlap, since it's an intersection, my answer has to be where they intersect. Where are they intersecting at? They're intersecting down here from negative infinity to negative 13 halves with a bracket. All right, that takes care of an and problem. 4 problems work the same way, except you don't have to break them into 2 pieces, you just have to solve them. So in this case, we would need to subtract 7 to get negative 16, divide by 3. Here, same thing, add 8, divide by 5. And of course, this one's got the automatic or in it. Ors are the same thing as unions. So we are going to join our solutions together in a union. If I put negative 16 thirds on the line and 2 on the line, okay, x is on the left, so the arrow is pointing us in the correct direction to shade. So that means I need to go less than negative 16 thirds. It's not equal to, so it needs a parenthesis. Or I need to go greater than or equal to. Sorry, should have done that. That was bad. I'm using interpolation, so I should have used a bracket, and I'm going greater than 2. Okay, do unions have to cross each other? No, they don't. All your solutions are everything you see shaded. This is very common for union problems that you get more than one piece. So when we write it, we just write two separate intervals, negative infinity to negative 16/3, parentheses, and then because it's two separate pieces, we say it's these or these, but instead of putting an or between it, we simply put a union between it. So it is possible to have final answers that contain union symbols in them. You will never have a final answer that contains an intersection. Intersection problems, you have to have found the intersections. So you will not ever have intersections in a final answer, but unions will happen all the time. Last but not least, this book chooses to begin a slight introduction of finding the domain of a function. They call it the allowable values. I want you to learn to call it domain because that's what it is, but yeah, we're talking about what values are allowed in this particular function. What x coordinates are we allowed to use, or actually more to the point, what x coordinates can we not use? So when you're doing domain, it's all about the set of possible x coordinates. Okay. If it's a rational function like this first one, a fraction, what is the one thing that you can never ever have in a fraction? You can never divide by 0. So your denominator can never equal 0. So when you see one with a fraction, you have to go, okay, my denominator can't equal 0. What in this case would make the denominator equal 0? Well, 3. So I would prefer, when it's just one number or two numbers we can't use, I would prefer you go x does not equal 3. However, you can do this in interval notation. I find it somewhat more annoying because you technically say is negative infinity up to 3, but not including it with a parenthesis, union with 3 on out to infinity. I find that cumbersome. I think x does not equal 3 is a lot easier to look at and go, yep, okay, everything's possible except 3. So I would prefer you use that notation. Okay, the other one, roots. These are the sticking point. You're going to be excited to see this. Square roots, even roots. If you have a root, a second square root, fourth root, sixth root, anything with an even root, what kind of numbers must be contained in even roots? They must contain positive values. So now you have to figure out where will this thing contain positive values. Okay. And this brings back a method you're going to be excited to see again. We find this by testing points because testing points let us find out where things were positive and negative. So here's a reminder of how we tested points. Figure out what number makes it equal 0, and then we test on either side of that. So in this case, what numbers make it equal 0? 2. Okay, we know one side of this will be positive, one side will be negative. Usually the easiest number we choose to pick is 0. So 0 would be on the left side of 2. If I put 0 in that function, will I get a positive or negative number? 0 minus 2 is negative. Okay, if I check the number on the high side, like 5, 5 minus 2 is positive. So I know then that the positive side is the side I want my solutions. So I would shade the positive side. Now the question is, can it equal 2? 2 makes it equal 0. Can you have the square root of 0? Answer, yes you can. Square root of 0 is 0. So we can have that answer, and our solution would be the interval 2 to infinity. Okay. Domains can get a whole lot trickier. They're nice on this assignment, and they do not get tricky with you. We will be seeing this over several times. Sometime in November, we're going to see a major section of domains. You're going to get very good at it, so this will be coming back to you. We will continue next time with doing problems that are absolute values and absolute value inequalities. They also have ands and ors, and this interval notation stuff is going to continue. So make it your friend. It's not going to go away. Good luck.